Hello friends, in this video I'd like to solve the following problem from Chile Mathematical Olympiad, final round 2014, problem number 4. We wish to prove that the following expression, n cubed minus 9 times n plus 27, is never divisible by 81 for any integer n. So this problem is rather easy, it's very easy to be honest. Here is my hint. Suppose to the contrary that our divisibility holds for some integer n, try to show that n must be 3 times some integer k, and that should very soon lead to a contradiction. So give this problem a try and I will see you in just a minute. Okay, so here is my solution. As I suggested, suppose to the contrary, suppose that 27 does divide n cubed minus 9 times n plus 27 for some integer n. Okay, so let's take a look. We see that this part is obviously divisible by 3. So n cubed must be also divisible by 3. So 3 divides n cubed. Well, but 3 is a prime number, and we know that a prime divides some power of an integer if and only if it divides this integer as well. So 3 divides n, which means, i.e., n equals 3 times k for some integer k. Okay, and now let's take a notice that our divisibility condition, namely this, is equivalent, sorry, not 27, but 81, I made a typo. And now, that means that 81 divides 27k cubed minus 27k plus 27, which in turn, after division by 27, is equivalent to saying that 3 divides k cubed minus k plus 1. Well, it cannot be. Why? Well, we have 3 cases. Let's take them separately. If k is congruent to 0 modulo 3, then k cubed minus k plus 1 is congruent to 1 and isn't congruent to 0 modulo 3. So we don't have a divisibility. Well, if k is congruent to 1 modulo 3, then k cubed minus k plus 1 is again congruent to 1 and not congruent to 0 modulo 3. And finally, if k is congruent to 2 modulo 3, we have 8 minus 2, but 8 minus 2 is 6. 6 is congruent to 0. So again, our number is congruent to 1 and not congruent to 0 modulo 3. So we get a contradiction. This, which I mark asterisk, cannot be true. It cannot be true. It's a contradiction. Which means that our initial claim, initial supposition was erroneous. It was false. So, in other words, for every integer n, 81 does not divide n cubed minus 9 times n plus 27. And that closes our proof. Thank you for watching, and I will see you next time. Goodbye.